Why is it that when we have an equation with a radical in it, otherwise known as a radical equation, we get answers, some of which work and some which don't? Um, so we know that when we solve something like this, we typically square the sides because we want to get rid of the radical. So before I get into this, I want to just give kind of like a fast answer. So let's look at something linear, x equals 4. And how many solutions are there to this? How many numbers could x be so that the left side equals the right side? And it's obviously only one answer. It's going to be a 4. If we square both sides, we know that this implies this. It doesn't mean it's the same thing though. If you solve this, how many solutions are there? Well, how many numbers could be squared to give 16? One would be 4 and one would be negative 4. So really, the fast answer to this whole thing is when you square, you produce the possibility of other answers. This is not the same kind of equation as this. This is linear, this is quadratic. This has one solution, this has two solutions. It doesn't mean there's anything wrong with what we did, squaring both sides, because I know I can do anything I want to one side of an equation as I do to, as long as I do it to the other, but it doesn't mean it's the same kind of equation. This is not the same thing as this. Okay, let's look at the radical equation again, which is this. And if I bring everything over to the left and solve it graphically, we see that we get 4. That would be the 0 or the root. And if we plug it in, well, then we get 2 equals 2. It works. Okay, so we know the solution is 4, but we wouldn't normally solve these graphically. We would do it this way. So we would square both sides and we would turn it into this, which would be this. So basically we turned it from a radical equation to a quadratic equation. And the first one only had a single solution, but because this is a quadratic, it's going to have two. By the fundamental theorem of algebra, we know that has to be the case. Well, we can see the 4 here that we already knew, but now another solution has been introduced because of the fact that this is a quadratic, and this is not a solution to the original radical equation. It's only a solution to the quadratic equation. So if we check both of these answers here, so 4 and 1, so here's the radical equation. If we plug 4 in, well, as we've already seen, it works. But if we plug 1 in, we get 1 equals negative 1. That does not work because this solution did not even ever belong to the original equation. It never had anything to do with it. So hopefully that kind of clears up why you can do everything right to a radical equation and end up with solutions that don't work.